Hello everyone. Today we're looking at compositions of transformations. This is essentially going to be a summation and review of sections 9.1, 9.2, and 9.3, reflections, translations, and rotations. So the general idea here is that when we take a transformation, apply that transformation to a figure, and then apply another transformation to the image created from that figure, we end up with something known as a composition of transformations, essentially taking multiple transformations and using them in sequence with each other. So in this first example, we're translating triangle QRS by the rule x minus 3, y minus 4, and then rotating the image we get, the Q prime, R prime, S prime, 270 degrees counterclockwise. Now, 270 counterclockwise, that's the same as 90 degrees clockwise, if you prefer to think about things in terms of clockwise notation. So the general idea here is we're going to start off with our basic coordinates. We're going to do things in the order the prompt tells us. In this case, it tells us to translate first. So you subtract 3 from each of our x's, subtract 4 from each of the y's to give us the coordinates of 1, negative 3, negative 2, negative 6, and negative 1, negative 1. We're then going to take these primed coordinates and rotate them 270 degrees counterclockwise, which essentially means we're going to swap the position of our x and y, and then we're going to swap the sign on our x's, such that the 1, negative 3 becomes negative 3, negative 1. Negative 2, negative 6 becomes negative 6, 2. Negative 1, negative 1 becomes negative 1, 1. And then we simply graph them out. Now I'm going to go ahead and pause the video to graph things out, and then I'll resume to explain. So we start off with our initial set here in black of our initial QRS triangle. Here in red, we have our primed translation of Q prime, R prime, S prime. And here in purple, we have our rotated of Q double prime, R double prime, and S double prime, showing us how the initial triangle has moved about our coordinate plane. So that's essentially what we're going to be doing for each of our problems. In guided practice number 1, we're going to translate triangle ALT by the rule of x plus 3, y plus 2, and then reflect it over the x-axis. So we head to our table. First things first, because it says translations are going to happen first, that's what I'm going to do first. So I'm going to add 3 to all of my x's, and then add 2 to all of my y's, such that I have an a prime value at negative 2, 1, L prime value at negative 1, 0, and a T prime value at 0, 4. It then wants me to reflect it over the y-axis. Reflecting over the y-axis means we're going to take our x and y and keep them in the same order, but we're going to swap the sign on our x coordinate. So a double prime is going to be 2, 1. L double prime is going to be 1, 0. And then T double prime is going to stay at 0, 4 because there's no such thing as a positive or negative 0. 0 is simply 0. So with our coordinates in mind, we then graph it out. Once more, I will pause and resume momentarily. So we have our initial figure here in black of our A, L, and T. In red, we have A prime, L prime, and T prime that we translated from our initial figure. And then we reflected to get our A double prime, L double prime, and T double prime by the reflection over the y-axis. Now we're going to do the same thing as the previous problem, except now we're going to swap the order. First, we're going to reflect, and then we're going to translate it. So first, we're going to reflect over the y-axis, which means that we're going to keep our x and y coordinates, but go negative for the x's, such that our a prime is going to be 5, -1. Our L prime will be 4, -2. And our T prime will be 3, 2. After we reflect, now we're going to translate. Our translation is going to be x plus 3, y plus 2, such that our a double prime will exist at 8, 1. L double prime will exist at 7, 0. And T double prime will exist at 6, 4. So this time, we still have our initial starting position, but we reflected over the y-axis, and we translated it to the right 3 units and up 2 units. So notice the compositions in guided practice 1 and 2 were the same transformations, but done in a different order. Using these examples, would you say the order matters? In fact, because we ended up in different locations, the order does matter. Now we're going to shift gears a little bit. Guided practice number 3 gives us a fully worked out set of numbers and coordinates. And it wants us to describe the composition of transformations. Personally, the easiest thing to do, in my opinion, is to pick a point and then follow that point around. So point B, 1, 3, becomes somehow B prime at 1, -3. That reads like a reflection across the x-axis. Then it seems to move brown 5 units to the left. So x minus 5 and y. Such that if we describe the composition of the transformations, our initial figure is being reflected over the y-axis and then shifted to the left 5 units. Last problem, guided practice number 4. What are the original coordinates of point B if point B was translated 3 units to the right and 4 units down, and then reflected across the y-axis? So we have here point B double prime as the final transformed point. And we want to figure out what the original point was. So given B double prime of -4 to 0, we want to figure out what the original point B was. The way we do this is by working backwards from the prompt. The last thing that happened to point B was it was reflected across the y-axis. So the first thing we're going to do to point B double prime is to reflect it across the y-axis to get B prime. So that's that B prime would be located at 4, 0. Now we look at the translation that occurred. Originally, point B was translated 3 units to the right and 5 units down. We're not going to do the same thing, though. We're not going to translate this B prime 3 to the right and 5 down. Instead, we're going to do the opposite of it. So instead of 3 units to the right, we're going to go 3 units to the left. So x minus 3. Instead of 5 units down, we're going to go 5 units up. so y plus 5, such that our original b value was located at 1, 5, indicating that it would be, if we were to graph it out, about there. And that's the notes. If you have questions on things, please ask. Otherwise, take care, and we'll touch base another time.